Well, this is a very small crowd, I see. Maybe someone will show up later. I will be interested in the end whether you like this idea of going through very specific problems of the technology or challenges and presenting solutions. The idea came to me through my work with customers. So I try to really find 7 challenging points, questions that came up again and again, and I'll try to present some answers for you. Yeah, who of you knows CDO already, has used it? I guess so. This format of the talk is a little bit more advanced than my usual talks. So I will not give an introduction to CDO. Depending on how fast we can run through the 7 recipes or the 7 challenging areas, I hope that we will have time for questions later. So just the history, CDO was born in 2003-04, so it's a comparatively old technology. In the years since that time, we've added a bunch of functionalities to CDO. Started comparatively small with a core set of functionality, and we added more and more. Most of these are optional functionalities. You can pick the ones you want and leave out the ones that are too complex or are too slow in your scenario, whatever. For all of these functions, we provide very nice APIs in CDO. You can use CDO as a user interface level tool as well, but this user interface is always built on the public APIs of CDO. And most of the recipes that we will run through in the next 30 minutes are related to proper API usage. Some are about configuration as well. In particular, we will look at the following 7 topics. We'll look at what mapping strategies are and how they differ, what are the best ones for you. On the client side, a question often comes up, do I need to regenerate my models or not? We will look at that, of course. Lazy loading is a very important part of CDO, but it also comes with some challenges, and I will show you ways how to deal with that. Querying is a very powerful sub-framework in CDO, so we will have a look at that too. The topic of large collections, how do they perform? That often comes up, so I will have some slides for you. Dealing with remote notifications is also something that works out of the box in CDO, but there are many things you can tweak, and I think it's important to understand that if you want to deploy a distributed model application to a network. And finally, there are some smaller hints regarding how you prevent yourself from other threats accessing the same model and stuff like that. Okay, let's start. The first recipe is about choosing the best mapping strategy. And that, of course, refers to the server side mostly. It's a configuration. And I'm not sure if you know, but CDO works in one of 3 different modes. The so-called normal mode is as simple as a normal database, I would say. If an application modifies an object graph and commits the transaction that has modified these objects, new revisions are created in the repository server, in the database. And the next commit of the transaction will override the former revisions. That means that is really what you have with normal databases. When you change a row, you don't have two rows, you lose the old data, right? Excuse me, that was the party yesterday. So the next mode, and that mode is called auditing. It has been in CDO from the beginning. So CDO was designed to support auditing. And auditing means that when the application changes the object graph a few times, we never lose the old data in the database. So we always create new rows, and the database will always grow and never shrink. So it has advantages and disadvantages, of course. Disadvantage is obvious, the database doesn't shrink. But the advantage is you can time travel through your model evolution, to the evolution of your model instances. We have in our exemplary user interface, for example, a time slider, and you can just slide it, and the model populates, depopulates, changes, and it's very easy to audit the model changes in time. And you see that this basically adds a second dimension in this, what we call revision space. The third mode that we support is branching. That is a little bit newer, and it adds a third dimension to the revision space, because every branch supports auditing as well. You can go back and forth in time, but you can also work parallel with teams, like you know it from Git. So depending on the repository mode that you've chosen, you need to select an appropriate mapping strategy. The mapping strategy that we support is always horizontal. Who of you does not know what that means? Please raise your hand. Okay. A horizontal mapping strategy means that the object relational mapper in CDO will create one table for each concrete class in your model. And this database table will have all the inherited, or will have columns for all the inherited attributes in your classes. The contrast, and funnily, formerly CDO had a vertical mapping strategy that is based on joins between tables. So you have one table for each, even for the abstract classes, and they are linked through joins. Storage is a little bit more efficient, but it's, of course, it takes longer to query this data. So we completely got rid of that, and we only offer horizontal mapping in the database. In fact, we have 5 different horizontal mapping strategies, and they depend on the mode that is chosen. So the implementation is really different whether you have auditing enabled or branching enabled. The most important thing is if you have auditing enabled or branching, and by the way, branching always includes auditing, so there is no branching without auditing. The reason that we have 2 different Boolean properties here, that's just a historical reason, because we started without branching. So when you have at least auditing enabled, data will not be overwritten in the database. And when you have larger collections in your objects, copying them from version to version can take quite a long time. So at some point we added 2 specialized mapping strategies for the cases auditing and branching, and we call them with ranges because they only store the deltas between the list changes. So if you work with auditing or branching, don't forget to switch that on. If you're interested in a complete list of all the configuration properties to configure a repository server, since I think 2 years we have a complete reference guide here and they are all explained in the help system. So, now that we have set up the server side, configured it properly, we of course want to execute an application on top of the repository server. And this application will have models. You have created these models typically. And the question often is, should I generate this model specifically for CDO, or should I use a normally generated model, normally in the way that how EMF does it? And we call this, we distinguish them, we say when you generate them for CDO, we call them native models, CDO native models. And if you don't do that, we call them legacy models. Formerly, you had to enable a so-called legacy mode in CDO to support that. That is not necessary anymore. They are supported out of the box. So they all work, even dynamic models. Dynamic models, you know what that is? You don't generate them, you just import an ecore file and start to create instances. CDO supports that too, and the instances will be native too. The main difference between native and legacy is that native models are scalable. That means CDO supports automatic garbage collection. Every single object, as soon as you don't reference it from your application anymore, can and will be garbage collected at some point. No matter how your model objects are related to each other, that is part of this regeneration, that you can safely iterate over a model with, let's say, 15 billion elements or so. It will take some time, of course, because they have to be loaded and unloaded, but it doesn't matter how big your local memory is. So I would say, when you have the chance, regenerate your models for CDO. If they are your own models, you typically have that chance. When you work with models like GMF notation or UML, stuff like that, you typically don't have the chance to just regenerate these models. They will still work, but they will not scale to the same extent as the CDO native models. Good, and we just saw on the slide before, especially when you work with native models, that lazy loading is supported for single objects. Yeah? In EMF, you typically, when you enter a resource, when you navigate into it, it is loaded on demand. In CDO, that is true for every single object. You can even, if you navigate a cross-reference to an object, that object will be loaded no matter what its containers are, whether they are loaded or not. And at the same time, as I mentioned before, they will be garbage collected as soon as you navigate further and don't hold on that object anymore. So lazy loading is the way to support scalability, of course. Only depends on the granule, and the difference between EMF and CDO is really just the granule of lazy loading. A more important difference is unloading. I just said CDO native models, the objects will be unloaded automatically. In EMF, you have probably seen this unload method of a resource. And this is just a hint from me. It doesn't make your resources reclaimable by the garbage collector. It's comparingly hard to explain. If you're interested why or why not, you can read my former article, How Scalable Are My Models? I try to explain it there. But be aware, when you call unload, you will use more memory than before, not less as you would expect. So you don't have these problems with CDO native models. Lazy loading is cool, but loading a single object from the server, that is a network round trip. So you can imagine you have models are typically tree structured, and your user drills down into a tree, opens nodes, and the children have to be loaded. So many network round trips will happen. And what you can do against that is that you come up with clever prefetching strategies. And now we will have a look how you can do that in CDO. There are many different ways how you can do it. Probably the simplest one is that you manually say, okay, the children of this object, please server, give them to me all at the same time. And you can specify a depth. You can say infinite or just the first 2 levels and so on. And in one server round trip you get the children. The same mechanism, just in a different form, more convenient form, is that when you load a resource through a URI, you can append that query prefetch equals true, and it will also be loaded as a whole in one server round trip. Makes especially sense for legacy models. Yeah? Legacy models do not support lazy loading, but imagine models can be mixed. A tree can have legacy objects here, then native objects, and whenever a legacy object is loaded, the children are loaded with multiple server round trips. So loading a resource with just legacy objects, typical example, a GMF diagram, can take quite a long time, so it's typically best to open that resource with prefetch equals true. So then we have some more advanced prefetching mechanisms. You can create policies where you don't have to say, okay, I want the children of this object, but whenever I load an object, server, give me the first 100 children, no matter what they are. That is what we call a prefetching policy. And even more advanced, probably also less used and tested, but is that you can configure a so-called feature analyzer. And we have multiple of those. A feature analyzer monitors how your application or your user is using your model. And it derives usage rules, we call them fetch rules. We send them to the server then, and whenever the user does something new, these fetch rules are evaluated, and we assume that he probably is about to do a similar thing as he did before, and we send him the objects already. So you see there are quite some mechanisms in CDO to work around the problems of lazy loading. Here I have a nice recipe which is very typical. Yeah, user interfaces often come with these tree viewers that display the model. And you really want to avoid that you have too many server round trips. If a tree node has, let's say, 1,000 children, you don't want to go to the server 1,000 times to load them. So this is a typical recipe that where I even have an example in CDO's own user interface that avoids this server hopping, this ping pong game with the server. And in fact you use CDO's lower level APIs. You access the revision data of an object, and there you can get the IDs of the children out. You don't load the children, you just have the IDs. And with these IDs you can do quite some interesting things. First you can say, does it have children? For an Eclipse content provider you must first render this plus icon if it has children. And ideally you don't want to load the children at that time. And with this mechanism that's not necessary. Then you can look in your local cache whether you have the objects of these IDs, and if not, you can load the missing ones in one chunk, and then you have a very reactive, lazy tree UI. There's an example in CDO if you want to look that up. That is our checkout content provider. It's, in my opinion, quite advanced, but not too much code. So have a look at that. So with CDO you can query data. Oh, I thought there's a slide missing. Must have deleted it accidentally. I'm sorry. I'm sorry, I'm sure there was a slide that shows how to query, and that is missing now. So you query in CDO, you know that you always have a view or a transaction. A transaction is also a view. This view provides and manages the e-objects for you. It loads them from the server when you need them, unloads them, and so on. So you can, when you want to query objects in the server, you say view.createQuery, and the query always has a query name and a query string. So CDO has this generic querying framework, and you can hook in your own query languages if you want. I will show that in a minute, how that works. Of course, CDO comes with built-in queries, and depending on what backend store you use, you have different query languages available. A typical example, if you use a relational database, you can query the data with SQL. If you use, let's say, objectivity as a backend for CDO, that comes with its own objectivity-specific query language. Yeah, let's have a look how that is done. Whenever a query request arrives at the server, the repository tries to find a query handler for that query. And I'll show you the code so that you understand how you can hook in your own query handlers and in what order they are evaluated. So first we have 3 built-in query languages. One is there to query the resources in the repository. And in fact, all these 3 built-in languages, they have proper API as well. So you can always say view.query resources instead of creating such a query and doing that manually. With the instances query, the second one here, you can query all instances of a specific class, including subtypes or not. You can configure that. So that is what in OCL typically an extent means, the extent of a class. And the last built-in query is for cross-references. So if you have a set of objects and you want to know what other objects point to them without iterating over the entire repository tree, you can query for the cross-references by saying view.queryxrefs. So when the query request that comes to the server is not one of these 3, the database backend is used as a query handler. Most people use SQL or a relational database, so SQL would be handled in this case. And if all that doesn't help, if the query language is something else, the server tries to find a registered query handler, and you can register your own ones. Here is a small example. If you, for example, want to know what users are currently logged into the repository, you could register a query handler, and with these 4 lines of code in the method body, everything is done, and you get that information to the client. Of course, you must register a factory with a repository so that your query handler is known, and that is done through plugin XML. So you can look that up later when I make my slides available. So the next recipe is about large collections. That topic comes up again and again. So the first question, this program here, what does it really do at what times? So it's comparatively simple. The program opens a view, it loads a resource, gets the first element out of that resource, casts it to a company, and then it iterates over the list of the customers. The question is, at what time are customers loaded? Does someone know it? Pardon? They are loaded lazily, exactly. So that means they are not loaded at the time the company is loaded, but each time the iterator next is called here, is a little bit hidden through the newer syntax, but in each for loop iteration, one customer is loaded. When the company is loaded, just a list of customer IDs is loaded, and they are comparingly small typically. So yeah, I can give you an example how you can see that in the console. You can register listeners with almost everything in CDO. Most things like views, transactions, sessions, all the managers and so on, they emit events, and you can always see what kind of events they emit, and so it's very easy to see what's going on under the covers. So with this small program you can see when exactly the customers are loaded. The bottom line is collections must be very large typically to become an issue. So if you think you have an issue, please test that first with real data before you try to use CDO features that do something against this problem. Make sure you have that problem. That is important. CDO does support partial collection loading. As you see down here, we have collection loading policies. This one says, whenever an object is loaded, give me the first 100 IDs of the collections, so IDs of the target objects. And when I iterate over such a collection that is partially loaded, whenever the loaded data is used up, it will load 10 new IDs. This is not related to the target objects, it's the IDs of the target objects. Yeah? The problem with this is there are many functions, newer functions in CDO, like everything that has to do with comparing objects or merging objects. It will load all the IDs, also all the collection elements anyway. So if you use partial collection, that makes it worse. You must load them anyway, but you will use several round trips in that case. So you should think about ways to avoid large collections. That is my personal opinion, but that is a very safe approach typically. Often it is possible to restructure your model in a way that you can insert intermediate containers. So instead of having one large collection, you split it up into several short, smaller ones. Sometimes there's not such a natural way. For example, you could group all the orders of a company into the months in the year. So you have a January container and stuff like that. We can discuss whether it's nice or not, whether it's natural or not. Sometimes it's feasible, sometimes it's not. And we have a quite interesting class in CDO that not many people know. It's called CDO balanced tree. So if you have objects that must be contained somewhere, and objects always must be contained somewhere, but you don't care where they are contained, you could use a CDO balanced tree to make sure that no node of this tree becomes larger than a number that you can specify. That is a nice way to avoid large collections. Okay, next recipe is about, time is almost over, right? Did you raise your card? 5 minutes? Okay, great. Remote changes. Yeah, you probably know when a user commits a transaction to the server persists the changes and then notifies other clients in the network. You can enable or disable that. When you disable it, you can manually say refresh my session and you will get the latest changes. So you have more control over when they appear. If you enable passive updates, and that is the default normally, you cannot really predict when these changes arrive at your site. Because other users commit when they want, and in CDO there's always a background thread that takes these network notifications and weaves the changes into your model. We call that the invalidation thread, and it belongs to each CDO view. So, I'm not sure if you heard, the objects that CDO provides are thread safe. So you can have multiple threads that use your object, your loaded model. And be aware, even if you say I have only one thread in my application, one own thread, there is always this background thread, this invalidation thread that weaves in the changes of other users in the network. So it is essentially always multi-threaded. And the next recipe in a minute will show some hints regarding that. You can control how much change info you get. There are different ways. The easiest way is that you can set a so-called passive update mode. The default is that the server only tells you that an object has changed, but not how. So that is the least amount of data that is sent to all the clients. When you want more, and that for every object, you can set the passive update mode to changes, and then you get the full change deltas. All these modes, they are valid then for all objects. So you cannot say for this object just the invalidations and for these objects the deltas. If you want to do something like that, you need to work with change subscription policies. The idea behind that is that you're normally only interested in change deltas if you have an adapter on an object that listens to these EMF notifications. And with such a change subscription policy, that is all automatically done. CDO realizes when an adapter is attached, it tells the server, from now on send change deltas because I'm listening to these changes. That is quite powerful, but be aware, there are additional server round trips, and the server allocates state. It remembers what objects are adapted or not. So try that out when you have large models. Good, last recipe is about multi-threading and safe access to your local models. Always keep in mind that at any time this background thread can change your model. So when you are navigating over it, and for example you're doing calculations that involve the state of multiple objects, and it's the same like in databases often, consider to use either read locks. You see that here, you can atomically read lock a set of objects, and that means no other client in the network can modify them, and then you're safe against changes, and then you can sum up the salaries of the customers or whatever safely. Locks are comparingly heavyweight. They require server interaction. They are very safe, of course. Another way of achieving something similar is that you lock the view. Since the last release of CDO, I think we have this nice sync exact method. And this piece of code means that everything that runs in this runnable cannot be interrupted by this background thread. So even if the server sends change notifications, they are queued up until the end of this block. Then they will appear and your calculations could be wrong in terms the server has a different sense of your model in the meantime, but at least you can finish it without being interrupted. Yeah, I'm happy that I managed all my 7 recipes. I wasn't sure about that, I must admit. But thank you for listening. I'm not sure, do we have time for questions? 2 minutes. If you have questions, then now, please. Okay, then thank you again and enjoy the rest of the conference.